For most of the time our species has existed, eating was not a daily certainty. Some days brought meat or gathered roots. Other days brought very little. The human body was shaped in environments where food depended on migration, weather, and chance. Hunger was not always a crisis. It was part of the natural pattern of survival. Yet in the modern world, food arrives with the clock, steady and predictable. If our biology formed in a world of irregular meals, what does it mean that we now eat every single day? Why were humans never designed to eat every day? For most of the time that humans have walked the earth, there was no concept of a daily meal. No morning routine built around food. No midday pause designed for eating. No evening expectation that nourishment would appear at a certain hour. Early humans lived in environments where survival depended on movement across landscapes shaped by seasons, migration patterns, and shifting climates. In such worlds, food was not scheduled. It was encountered. It was found. And sometimes, it was not found at all. To understand why humans were never designed to eat every day, we must begin with the environment that shaped the human body long before agriculture, markets, or clocks existed. Across much of the Pleistocene epoch, which spans nearly all of Homo sapiens' evolutionary history, small groups moved through savannas, woodlands, river valleys, and later colder steppe environments. These were not places of guaranteed abundance. Large game animals migrated unpredictably. Plant foods appeared only during certain seasons. A successful hunt could provide energy for days. A failed hunt could leave a group searching for alternative sources, sometimes with little success. The rhythm of life was defined not by 3 meals, but by availability. Archaeological evidence from Paleolithic sites reveals patterns consistent with irregular food access. Animal bones at habitation sites often indicate episodic abundance, where a large carcass was processed thoroughly. Between such events, the record can appear sparse. This does not mean people were constantly starving. It means their access to energy fluctuated naturally. In this fluctuating world, hunger was not an abnormal signal. It was woven into daily existence. From the perspective of environment, eating every single day was not always possible. A hunting party might return empty-handed. A drought could reduce plant growth. A sudden cold period could shift migration routes. The human body, developing within this uncertainty, did not evolve around the expectation of constant intake. Instead, it adapted to cycles, periods of nourishment followed by periods of reduced availability. These cycles were not occasional accidents. They were structural features of ancestral life. Even in more temperate African landscapes, where early Homo species first evolved, food availability was seasonal. Fruits ripened and disappeared. Tubers required effort and time to extract. Small game was inconsistent. The idea that a human would reliably consume substantial calories every 24 hours would have been foreign across most of evolutionary time. What mattered was flexibility, the capacity to eat when food was present, and to endure when it was not. This environmental backdrop shaped metabolism long before civilization introduced predictability. It also shaped behavior. Hunger motivated exploration, cooperation, and innovation. It pushed groups to follow herds, to learn landscapes, to develop tools. In a world without storage technology beyond what could be dried or shared immediately, energy intake was intimately tied to success in that moment. There was no surplus system that guaranteed tomorrow's breakfast. The body that emerged from this long pre-agricultural history carries the imprint of those conditions. It is a body accustomed to variability rather than constancy. When we ask why humans were never designed to eat every day, we are not suggesting that daily eating is harmful by definition. We are recognizing that the evolutionary context in which our physiology formed did not revolve around regular clock-based feeding. It revolved around opportunity. The environment offered food in pulses, and the body learned to respond to those pulses. That ancient landscape, with its shifting seasons and uncertain hunts, remains the quiet starting point of our metabolic story. If we slow our perspective even further, beyond individual hunts or seasonal shifts, we begin to see how deeply irregular food access was embedded in the fabric of early human life. For small bands of hunter-gatherers, daily survival required constant attention to landscape, weather, and animal behavior. There was no fixed territory with guaranteed yield. Groups often moved in response to drying water sources, changing plant growth, or the migration of prey. In such settings, food intake depended on successful alignment with these environmental patterns. The expectation of eating every single day would not have been biologically realistic across most of this long evolutionary span. The archaeological record offers subtle but consistent clues. Campsites from different periods show evidence of repeated occupation, yet they rarely indicate stable, long-term accumulation of stored food in pre-agricultural contexts. While drying meat or preserving certain resources likely occurred, storage capacity was limited by technology and mobility. Carrying heavy reserves across large distances was costly. The structure of hunter-gatherer life favored movement over permanence. Mobility, in turn, constrained accumulation. Without large-scale storage, caloric intake was naturally tied to immediate success. In this way, irregular eating was not a chosen lifestyle. It was a structural feature of how humans lived. From the perspective of human origins in Africa, this pattern stretches back hundreds of thousands of years. Early Homo sapiens and earlier hominin species inhabited environments characterized by variability. Rainfall patterns fluctuated. Grasslands expanded and contracted. Animal populations rose and fell. Paleoclimate data show repeated cycles of wet and dry periods across African regions that shaped early human evolution. These fluctuations would have influenced the reliability of both plant and animal foods. A body evolving under such dynamic conditions would not calibrate itself to rigid daily intake. Instead, it would adapt to oscillation. Irregular access to food also influenced group behavior. Sharing played an important role in buffering risk. If one individual secured a large animal, the caloric return was distributed. This social mechanism reduced the likelihood that a single person would go without food for extended periods. Yet even with sharing, intake varied across days. A large carcass might provide abundance temporarily, followed by leaner intervals. This collective structure softened extremes but did not eliminate variability. The environment still dictated the rhythm. When we imagine early humans waking at sunrise, we should not picture a planned breakfast. We should picture uncertainty. Some mornings likely began with leftover marrow or dried meat. Others began with nothing more than the search itself. The metabolic systems of those bodies, our ancestral bodies, were tuned to operate under such uncertainty. Hunger signals emerged not as signs of system failure but as cues for action. The capacity to function cognitively and physically without immediate food intake would have conferred an advantage in these landscapes. Over many generations, individuals who could tolerate gaps between meals while remaining alert and capable were more likely to survive and reproduce. This long exposure to fluctuating intake formed the backdrop against which modern expectations of constant feeding now appear unusual. The daily, scheduled consumption that defines much of contemporary life represents a recent development in the arc of human history. In contrast, the world that shaped our biology was one of irregular opportunity. To understand why humans were never designed to eat every day, we must continue tracing this deep alignment between environment and physiology, recognizing that the body's story begins not with the clock, but with the landscape. Across tens of thousands of years, the human day did not revolve around eating. It revolved around movement, observation, and adjustment. Early humans woke into landscapes that did not promise provision. The sun rose over plains where animals might or might not appear. It rose over forests where fruiting trees were abundant one season and empty the next. It rose over riverbanks that could provide fish in certain months and offer little in others. In these environments, the structure of the day was organized around seeking, not consuming. Eating was an outcome, not a schedule. To understand why humans were never designed to eat every day, we must imagine daily life before food became predictable. Anthropological studies of more recent hunter-gatherer societies, while not identical to Paleolithic groups, offer cautious insight into this rhythm. In many such societies, food acquisition varies considerably from day to day. Some days involve successful hunts or productive gathering, other days yield little. Over time, these fluctuations average out, but the pattern remains irregular. This suggests that variability, not consistency, was a common feature of human subsistence. Such patterns likely echo deeper evolutionary realities extending back to our origins. From the perspective of biological design shaped by natural selection, What mattered was not whether food appeared every day, but whether energy balance could be maintained across longer spans of time. The body did not need a daily intake guarantee, it needed flexibility. It needed the capacity to store energy when food was abundant, and to mobilize that energy when it was not. This capacity is visible in our ability to convert excess calories into stored fat, and to shift metabolism toward fat utilization during fasting periods. These mechanisms did not emerge in a world of refrigerators and grocery stores. They emerged in landscapes where food pulses alternated with scarcity. Even cognitive function was shaped under these conditions. A brain capable of remaining alert during hunger would support continued searching and problem-solving. If mild to moderate hunger immediately incapacitated individuals, survival would be compromised. Instead, the human nervous system evolved to tolerate periods without food while maintaining awareness. This tolerance does not imply that prolonged starvation was harmless. It simply indicates that the body was not calibrated to panic at the absence of one meal. The expectation of eating every single day, at roughly the same intervals, is a recent cultural construct, rather than an ancient biological requirement. When agriculture appeared roughly 12,000 years ago, it gradually introduced greater regularity into food supply. Even then, daily certainty was not universal. Crop failures, seasonal lean periods, and social inequality still shaped intake. Only in the last few centuries, and especially in the last few decades, has consistent daily access become widespread in many parts of the world. Against the backdrop of 200,000 years of Homo sapiens history, this stability is brief. When we consider why humans were never designed to eat every day, the answer lies not in a dramatic evolutionary error, but in context. The context was a world of shifting climates, mobile groups, and uncertain returns. The human body that emerged from that world reflects its patterns. It carries within it the quiet memory of days when eating was possible, and days when it was not, and survival depended on enduring both without collapse. Hunger is often described today as a problem to be solved immediately. It is treated as a warning light, a sign that something has gone wrong and must be corrected without delay. Yet if we look at the deeper biological mechanisms behind hunger, we begin to see a different picture. Hunger is not simply a crisis signal. It is a regulatory system shaped across hundreds of thousands of years, designed to guide behavior in environments where food was uncertain. To understand why humans were never designed to eat every day, we must examine hunger not as discomfort, but as communication from a body built for variability. At the physiological level, hunger is influenced by a network of hormones and neural pathways. One of the key hormones involved is ghrelin, often called the hunger hormone. Ghrelin levels rise before meals and fall after eating. Yet this rise does not necessarily mean the body is in danger. It reflects anticipation and rhythm. In modern settings, ghrelin can increase at habitual meal times, even if caloric stores are sufficient. This suggests that hunger cues are shaped by patterns of expectation, not solely by energy deficiency. From an evolutionary perspective, this flexibility would have been advantageous. In ancestral environments, the body could not rely on consistent intake. It needed mechanisms that encouraged seeking behavior when energy was required, while still allowing functional performance during temporary absence of food. Hunger, therefore, acted as a motivator rather than an alarm. It nudged movement, exploration, and cooperation. It did not automatically signal collapse. When early humans went several hours or longer without food, their bodies did not shut down. Instead, metabolic systems adjusted. Glycogen stores in the liver provided short-term energy. As those stores diminished, the body could begin shifting toward fat utilization. This metabolic transition is not an emergency adaptation invented in modern times. It reflects a deep evolutionary capacity for fuel switching. The ability to move between carbohydrate and fat as primary energy sources allowed early humans to function across fluctuating intake. Such flexibility would have been essential in landscapes where a successful hunt might be followed by days of minimal return. The brain, which consumes a significant portion of daily energy, is particularly relevant in this discussion. It requires steady fuel, yet it too evolved under conditions of irregular eating. Mild to moderate hunger does not immediately impair cognitive function. In some cases, Heightened alertness may even occur during short-term food scarcity, supporting focused search behavior. This pattern makes sense in an ancestral context. If hunger rapidly disabled cognition, individuals would struggle to secure the very resources needed for survival. Instead, the human nervous system developed tolerance for gaps between meals. None of this implies that extended deprivation was harmless or desirable. Severe starvation carries clear risks. The point is more subtle. The human body was shaped in an environment where not eating every day was sometimes unavoidable. Hunger, in that context, was expected. It was part of the operating system of survival. When we feel hunger today between scheduled meals, we often interpret it as something abnormal. Yet biologically, it may reflect a system designed to operate within fluctuating patterns. As we continue asking why humans were never designed to eat every day, we begin to see that the answer lies not only in environment, but in the quiet logic of hormones and metabolism that evolved to match that environment. Beyond ghrelin and the initial sensation of hunger lies a broader regulatory network that governs how the body manages energy over time. Hunger is only the visible surface of a deeper metabolic design. Beneath it operates a coordinated system involving insulin, glucagon, cortisol, and neural circuits within the hypothalamus. These systems did not evolve in a world of predictable daily intake. They evolved in environments where energy arrived irregularly and had to be stored, conserved, and mobilized with precision. To continue understanding why humans were never designed to eat every day, we must look more closely at how this internal balance was shaped by long stretches of fluctuating access to food. When food is consumed, insulin rises to facilitate the storage of glucose and other nutrients. Excess energy can be converted into glycogen for short-term use or into fat for longer-term storage. In a landscape where abundance was episodic, this storage process would have been essential. A successful hunt or gathering event might deliver more calories than were immediately required. The body's ability to store that energy efficiently would increase the likelihood of surviving the next lean period. Insulin sensitivity, in such contexts, was not a flaw. It was protective. Between meals, especially when meals were separated by many hours or even days, insulin levels would fall and glucagon would rise. This hormonal shift allows the release of stored energy back into circulation. Glycogen is broken down first. When glycogen becomes limited, the body increasingly turns to fat reserves. This metabolic transition is sometimes described today in technical terms, but its roots are ancient. It reflects an organism prepared to alternate between feeding and fasting states. Such alternation was not rare in early human environments. It was structurally embedded in daily and seasonal life. Cortisol, often associated with stress, also plays a role in maintaining blood glucose during periods without food. In moderate levels, it supports energy mobilization and alertness. In ancestral settings, brief elevations during hunger would help sustain physical and cognitive performance. The body was therefore equipped not merely to endure the absence of food, but to remain active within it. This resilience would have been crucial for a species that depended on coordinated hunting, tool-making, and social cooperation. Even the brain's regulatory centers reflect this design. The hypothalamus integrates signals about energy status and adjusts appetite accordingly. Yet it does not demand constant intake. It responds dynamically, allowing for periods of reduced consumption without immediate breakdown. The human organism, shaped over deep evolutionary time, learned to operate within cycles. It stored when possible, released when necessary, and maintained function across variation. This dynamic equilibrium stands in contrast to the modern expectation of continuous feeding. When meals arrive at fixed intervals regardless of energy need, hormonal patterns shift. The body still follows its ancient programming, storing and releasing according to signals it interprets through evolved pathways. To recognize that humans were never designed to eat every day is to recognize that our hormonal architecture anticipates fluctuation. It does not assume uninterrupted supply. It was forged in landscapes where the absence of food was not an anomaly, but an expected phase within the broader rhythm of survival. If we step back from individual hormones and consider the full metabolic picture, a quiet pattern emerges. The human body is not optimized for a constant stream of incoming energy. It is optimized for regulation across cycles. These cycles include feeding, storing, mobilizing, and adapting. When food is present, the body engages processes that capture and conserve energy. When food is absent, it does not immediately collapse. It transitions. This capacity to transition is not a modern wellness discovery. It is an ancient biological inheritance rooted in the environments in which Homo sapiens first emerged. To continue asking why humans were never designed to eat every day, we must understand this transition as central to our design rather than peripheral. In ancestral landscapes, irregular access to food was not rare or extreme. It was embedded in daily life. The body that could endure hours, sometimes longer, without intake while remaining mobile and attentive had a survival advantage. Such endurance did not mean prolonged starvation without consequence. It meant the ability to tolerate natural gaps between successful hunts or gathering events. Over time, natural selection would favor organisms capable of metabolic flexibility, those who could draw from internal reserves without severe impairment. This flexibility includes the shift from glucose-based energy use toward greater reliance on fatty acids and, in extended cases, ketone bodies. The biochemical pathways for these transitions are deeply conserved and present across human populations. They did not arise in response to recent dietary trends. They reflect long-standing evolutionary pressures. Even in contemporary physiology, short periods without food do not automatically trigger harm. Instead, the body adjusts gradually, guided by internal cues and hormonal changes. The experience of hunger may fluctuate in intensity, rising and falling in waves rather than climbing steadily toward crisis. This wave-like pattern suggests that hunger is not a simple countdown to failure, but part of a regulatory rhythm. In early human contexts, this rhythm would align with environmental unpredictability. A missed opportunity for food would not immediately threaten survival if previous intake had been sufficient and storage mechanisms were intact. Another layer of this design becomes visible when we consider energy expenditure. Early humans expended energy through movement, tool production, and social coordination. Their bodies were accustomed to balancing input and output across uneven terrain and variable climates. The metabolic system was not built around minimizing hunger sensations at all costs. It was built around maintaining function through variability. When viewed in this light, the modern expectation that eating must occur at regular daily intervals appears historically recent. Only with agriculture and later industrial food systems did consistent supply become common in many regions. Yet the underlying biology remained anchored in older patterns. To say that humans were never designed to eat every day is not to suggest that daily eating is inherently wrong. It is to recognize that our metabolic systems evolved without the assumption of uninterrupted intake. The body was shaped in environments where energy came in pulses and was managed carefully between them. That ancient rhythm, feeding and fasting, storing and releasing, continues quietly beneath the surface of modern life, reminding us that the human organism was formed in a world where irregularity was normal. When we turn from physiology to the material traces left behind in stone and bone, a different layer of evidence begins to speak. Archaeology does not record hunger directly. It records tools, hearths, animal remains, and the quiet patterns of habitation. Yet within those traces lies indirect testimony about how often food was acquired and consumed. To understand why humans were never designed to eat every day, we must consider what the archaeological record reveals about the rhythm of hunting and gathering across deep time. At many Paleolithic sites, especially those associated with large game hunting, animal bones appear in concentrated clusters. These clusters often indicate single successful events in which a large animal was processed thoroughly. Cut marks on bones show systematic butchering. Long bones were cracked to extract marrow. Skulls were opened to access nutrient-rich tissues. Such evidence suggests episodes of abundance moments when a group secured significant caloric return at once. What the record does not show, however, is evidence of continuous daily procurement at equal intensity. Instead, it shows pulses, periods of activity followed by quieter layers with fewer remains. This pattern aligns with the ecological realities of hunting. Large prey were not captured on a predictable daily schedule. Success depended on tracking, coordination, and favorable conditions. Some days would yield substantial reward. Other days would yield none. In mobile hunter-gatherer systems, a large animal might provide energy that lasted beyond a single day, especially if shared among group members. Yet even with sharing, intake would fluctuate. The archaeological layers reflect this uneven distribution. Sites in open steppe regions often reveal repeated occupation tied to seasonal migrations of herd animals. Human groups returned when animals were present and moved on when they were not. Such seasonal rhythms imply that food access was structured by environmental timing rather than daily expectation. In forested or riverine environments, evidence of plant processing tools, grinding stones, digging implements suggests reliance on gathered foods. Yet even here, plant availability was seasonal. Fruits ripened briefly. Tubers required effort and knowledge to locate. There is little indication that Paleolithic communities had access to constant, year-round abundance sufficient to guarantee uniform daily intake. Storage technologies during much of the Paleolithic were limited. While drying meat or caching certain resources likely occurred, large-scale preservation was constrained by mobility and environmental conditions. Groups moved frequently to follow prey and water sources. This movement limited the accumulation of surplus beyond what could be transported. Without stable long-term storage systems, food security depended on continued engagement with the landscape rather than reliance on reserves. Across Africa, Europe, and Asia, archaeological evidence consistently portrays subsistence as opportunistic and adaptive. It reflects a world where food was encountered in cycles linked to migration, climate, and ecological variation. There is no clear sign of daily provisioning as a structural norm in pre-agricultural contexts. Instead, there are signs of variability, resilience, and careful extraction of nutrients when available. When we examine these traces through the lens of evolutionary design, a consistent theme emerges. The human body did not evolve in an environment of guaranteed daily meals. It evolved alongside a subsistence strategy marked by fluctuation. The stone tools and fractured bones scattered across ancient campsites quietly affirm this pattern. They suggest that irregular access to food was not an anomaly, but a defining feature of ancestral life, shaping the metabolic flexibility that remains with us today. If we look more closely at the layers of occupation preserved in ancient sites, a quieter pattern becomes visible. Archaeological strata often show cycles of presence and absence. A cave might contain evidence of intense activity during one phase, multiple hearths, abundant bones, stone tools shaped and reshaped, followed by thinner layers with fewer remains. These fluctuations do not necessarily reflect permanent abandonment, but they suggest shifting use tied to ecological opportunity. Human groups moved when resources required it. Their eating patterns would have moved with them. To understand why humans were never designed to eat every day, we must read these layers not only as records of habitation, but as records of variability in access to food. In many Upper Paleolithic sites across Eurasia, large accumulations of animal bones appear in association with specific seasons. Analysis of tooth eruption patterns and growth rings in animal teeth allows researchers to estimate when animals were hunted. In several cases, evidence suggests that certain sites were occupied primarily during migration seasons. This implies that people positioned themselves strategically to intercept herds at predictable times of year. During these windows, food would have been abundant. Outside those windows, the same landscape might offer far less. The archaeological record, therefore, captures seasonal pulses of caloric availability rather than a steady daily intake. Plant remains tell a similar story. Charred seeds and fragments of gathered foods appear in contexts that align with particular growth cycles. Even when plant processing tools are present, their use corresponds to seasonal productivity. There is little indication that wild plant foods could sustain stable, year-round abundance in most Paleolithic environments. Climate fluctuations during the Pleistocene further complicated this picture. Shifts in rainfall, temperature, and vegetation would alter local ecosystems over decades and centuries. Human groups adapted by adjusting their movements and strategies. Such adaptation reinforces the idea that regular daily intake was not the structural norm. Instead, intake was embedded within broader environmental cycles that unfolded across weeks, months, and seasons. Evidence from African Middle Stone Age sites also supports this variability. Faunal assemblages show a mix of small and large game, suggesting opportunistic hunting rather than uniform success. In some layers, Evidence of intensive processing indicates careful extraction of marrow and other nutrient-dense tissues. This thoroughness suggests that when animals were secured, their caloric value was maximized. Such behavior makes sense in environments where future access was uncertain. It reflects a mindset oriented toward episodic abundance rather than constant replenishment. Even spatial organization within sites hints at variability. Certain hearth areas contain dense clusters of remains, implying communal consumption after successful hunts. Other areas show lighter traces, consistent with shorter stays or leaner periods. The archaeological record does not present a portrait of daily certainty. It presents a portrait of adaptation to irregularity. When we consider why humans were never designed to eat every day, these patterns offer quiet confirmation. The material evidence of ancestral life reveals subsistence tied to ecological rhythms rather than clock-based schedules. Food came in waves shaped by migration, growth cycles, and climatic shifts. The human body that evolved within these waves developed the capacity to navigate them. The stones and bones left behind do not speak in words, but they suggest a long history in which irregular eating was not abnormal. It was simply the way life unfolded across the deep time of human origins. If we widen the lens further, beyond individual sites and seasonal patterns, we begin to see that irregular eating was not confined to one region or one period. It was a recurring theme across continents and across tens of thousands of years. From the savannas of Africa to the steppe tundra of Eurasia, early human subsistence followed the structure of ecosystems rather than the structure of calendars. Archaeological comparisons between distant regions reveal the same underlying principle. Food availability fluctuated, and human groups adapted accordingly. This broader pattern deepens our understanding of why humans were never designed to eat every day. In coastal environments, for example, shell middens, large accumulations of discarded shells, indicate periods of intensive harvesting. These deposits can grow rapidly during favorable seasons when marine resources are abundant. Yet even in these contexts, evidence suggests episodic use rather than continuous exploitation at uniform daily levels. Tidal cycles, seasonal migrations of fish, and storm patterns shaped when food could be reliably gathered. People adjusted to these windows. The archaeological record captures moments of concentration, not an uninterrupted daily flow. In inland river valleys, similar variability appears. Fish remains often correspond to spawning seasons when catches were more predictable. Outside those periods, reliance would shift toward terrestrial hunting or gathered plants. Such flexibility required mobility and knowledge, but it did not guarantee equal intake each day. The presence of specialized tools, harpoons, nets, grinding stones, demonstrates innovation in food acquisition. Yet innovation did not eliminate fluctuation. It reduced risk, but it did not create permanent stability. Even isotope analysis of ancient human bones provides indirect insight. Ratios of carbon and nitrogen isotopes reveal the types of foods consumed over extended periods. These data show diversity in diet across regions and times, reflecting adaptation to local ecologies. They do not indicate uniformity. Instead, they highlight how human groups adjusted to what landscapes offered. This dietary diversity implies variability in timing and quantity as well. A species adapted to consistent daily intake would likely display different metabolic signatures over deep time. Instead, what we see is flexibility. Climatic instability during the Pleistocene further reinforces this conclusion. Rapid climate shifts, known as stadials and interstadials, altered habitats within relatively short geological spans. Human groups responded by changing migration routes, tool technologies, and subsistence strategies. In such unstable environments, rigid daily expectations would have been maladaptive. Resilience depended on tolerating uncertainty and capitalizing on abundance when it appeared. The archaeological record, viewed across continents, suggests that irregular access to food was a structural feature of human evolution rather than a local anomaly. There is no strong evidence that pre-agricultural populations lived with guaranteed, evenly spaced meals across generations. Instead, there is consistent evidence of pulses of hunting events, harvest seasons, migration windows. These pulses shaped how energy was acquired and distributed within groups. When we return to the central question, why humans were never designed to eat every day, the accumulated evidence from stone tools, faunal remains, seasonal markers, and isotopic signatures converges quietly. It points toward a species formed within ecological variability. The human body evolved not around daily predictability, but around adaptation to change. The material traces of our ancestors suggest a long history in which eating followed opportunity rather than routine, and survival depended on enduring the spaces between. If irregular eating was a structural feature of ancestral life, then the body had to develop a way to survive within that structure. The answer was not simply endurance, it was storage. One of the most defining characteristics of human metabolism is its ability to convert surplus energy into fat and to preserve that fat efficiently. In modern contexts, this capacity is often viewed negatively. Yet in the environments where Homo sapiens evolved, the ability to store energy was not a liability, it was protection against uncertainty. To understand why humans were never designed to eat every day, we must examine why the body prioritizes saving energy rather than burning it immediately. Fat tissue is not inert. It is metabolically active and hormonally responsive. It functions as a long-term energy reserve, capable of sustaining the body when food intake declines. In a world shaped by migration cycles, shifting climates, and unpredictable hunts, this reserve would have been essential. A successful hunt yielding a large animal might provide caloric abundance for a short period. The body's response to such abundance was not to assume that similar intake would continue tomorrow. Instead, insulin and related pathways facilitated storage. Excess calories were converted and held in reserve. This pattern makes sense only within an evolutionary context where future access was uncertain. The preference for storage over immediate expenditure is not random. It reflects deep selection pressures. Individuals whose bodies efficiently preserved energy during times of abundance were more likely to survive subsequent lean periods. Over many generations, this trait became embedded in the species. The modern discomfort with fat accumulation often overlooks its original adaptive function. In ancestral landscapes, insufficient storage posed a greater threat than excess. The environment rarely provided continuous surplus. It provided pulses. Those pulses required careful management. From the perspective of early human origins in Africa, environmental variability was constant. Periods of drought alternated with wetter phases. Grasslands expanded and contracted. Animal populations fluctuated in response. Such instability meant that reliable daily intake could not be assumed across years, let alone across generations. A body designed for daily caloric constancy would struggle under these conditions. Instead, the human body developed a bias toward conservation. It learned to interpret abundance as temporary. Even today, this bias is visible in how readily the body stores excess energy and how cautiously it releases long-term reserves. Fat mobilization occurs when intake declines, but it does so through regulated pathways rather than rapid depletion. This regulation suggests that the body anticipates fluctuation. It does not operate as though daily feeding is guaranteed. In Paleolithic contexts, such regulation would allow groups to navigate days of scarcity without immediate collapse. The presence of body fat in skeletal populations from various prehistoric contexts indicates that moderate energy reserves were common and likely beneficial. Storage capacity was part of survival strategy, not evidence of excess. When we consider why humans were never designed to eat every day, the logic of energy storage becomes central. The body was not engineered to require uninterrupted intake. It was shaped to oscillate between acquisition and conservation. Fat served as a bridge between these phases, allowing survival across irregular access to food. This bridge was not a flaw in design. It was a response to the deep environmental realities that defined human evolution, where tomorrow's meal was never guaranteed and preparation for absence was wiser than assumption of certainty. Energy storage does not exist in isolation. It is part of a larger system that constantly weighs incoming signals against long-term survival. When early humans encountered periods of abundance, the body did not interpret this as a permanent shift in environment. It responded conservatively. Surplus energy was directed toward reserves because over evolutionary time, abundance was rarely stable. The metabolic architecture that prioritizes conservation over waste reflects a history in which unpredictability, not stability, defined survival. To continue understanding why humans were never designed to eat every day, we must consider how deeply this conservative bias runs. From a biological perspective, storing energy is safer than assuming that supply will remain constant. Glycogen stored in the liver and muscles provides short-term buffering, but these stores are limited. Fat tissue, by contrast, represents long-term insurance. Its caloric density allows substantial energy to be carried without requiring constant replenishment. In ancestral contexts where hunting outcomes varied and plant availability shifted with seasons, this insurance would reduce vulnerability. Individuals capable of building and maintaining moderate reserves were better equipped to withstand days or even longer periods of reduced intake. This does not imply that prehistoric populations lived in cycles of extreme feast and famine in a dramatic sense. The pattern was more subtle. Intake fluctuated within a range shaped by environment and skill. The body responded by smoothing these fluctuations internally. Storage allowed external irregularity to be absorbed without catastrophic consequence. Over time, this smoothing function became embedded in human physiology. Even today, the body does not immediately relinquish fat stores at the first sign of reduced intake. Release is gradual and hormonally regulated. This restraint reflects an underlying assumption built into our biology. Scarcity may persist longer than expected. The preference for saving rather than rapidly expending energy can also be understood through the lens of natural selection. Across generations, individuals who wasted surplus energy during brief periods of abundance would be more vulnerable during subsequent lean phases. Those who conserved had a survival advantage. This evolutionary filtering occurred over hundreds of thousands of years, shaping metabolic pathways that err on the side of caution. In this light, the tendency to store energy is not evidence that humans were designed for constant feeding. It suggests the opposite. It suggests that the body evolved in anticipation of gaps between meals. The presence of adipose tissue as a dynamic, hormonally active organ further underscores this point. Fat cells respond to insulin, leptin, and other signals, integrating information about energy status. They communicate with the brain, influencing appetite and expenditure. This feedback loop evolved within contexts where intake could not be assumed daily. The system's goal was stability across time, not constant throughput. When we revisit the central question why humans were never designed to eat every day, the logic of conservation becomes clearer. A species adapted to predictable, uninterrupted feeding would prioritize immediate utilization and minimal storage. Instead, humans developed a physiology oriented toward accumulation and careful release. This orientation makes sense only in a world where tomorrow's meal was uncertain. The bias towards saving energy quietly reveals the environmental history embedded within our bodies, a history in which irregular eating was not an exception but a recurring condition woven into the long arc of human survival. If energy storage was an adaptive response to irregular access, then the way that energy is released tells us even more about the environment in which humans evolved. The body does not empty its reserves recklessly. It releases stored fuel in measured stages, preserving function while extending survival. This layered release reflects caution shaped by deep evolutionary time. To understand why humans were never designed to eat every day, we must observe not only that energy is stored, but how carefully it is used when intake pauses. When food consumption decreases, the body first draws upon glycogen stored in the liver. These stores can sustain blood glucose for a limited period. Only after glycogen begins to decline does the body increasingly mobilize fat. This transition is gradual and regulated. Hormones coordinate the shift so that essential tissues, particularly the brain, continue receiving energy. The existence of this multi-stage system implies anticipation of intermittent intake. It is not designed for immediate crisis at the absence of one meal. It is designed to bridge natural gaps. Even muscle tissue is not rapidly broken down during short-term fasting. Protein conservation mechanisms protect structural integrity in the early phases of reduced intake. Only in prolonged deprivation do more severe catabolic processes begin. This hierarchy of energy use suggests that the body expects fluctuation, but also expects recovery. It assumes that after a period without food, nourishment will return. This expectation aligns with ancestral conditions in which lean intervals were temporary rather than permanent. The architecture of release, therefore, mirrors the architecture of storage. Both are conservative. Both assume variability rather than constancy. In the Pleistocene landscapes where Homo sapiens developed, this system would have allowed individuals to maintain mobility and cognition across days when hunting failed or gathering was limited. A body that panicked metabolically at the first missed opportunity would be maladaptive. Instead, evolution favored resilience. Resilience did not eliminate hunger sensations, but it buffered their physiological impact. There is also a population-level dimension to consider. In small groups, not every individual would secure food equally on every occasion. Sharing reduced extremes, yet intake still varied across members and across days. A metabolic system capable of stabilizing energy internally would help smooth these interpersonal fluctuations. Over generations, such smoothing mechanisms would become widespread within the species. When we reflect on why humans were never designed to eat every day, the controlled nature of energy release offers quiet confirmation. The body behaves as though it anticipates intervals without intake. It does not treat them as abnormal interruptions. Instead, it follows a sequence developed over hundreds of thousands of years. Draw from immediate stores, transition to longer reserves, preserve vital tissues, remain functional. This sequence only makes sense within an evolutionary history marked by irregular access. The modern expectation of uninterrupted daily meals is recent. The biological blueprint beneath it remains older. It carries the imprint of environments where food arrived in waves and where survival depended not on constant supply, but on the ability to endure the space between abundance and the next opportunity. Long before agriculture reshaped landscapes, periods without food were not extraordinary events. They were woven into the ordinary structure of human life. The word fasting today often carries religious, cultural, or health-related meanings, but in deep evolutionary time, it described a biological reality rather than a chosen practice. Early humans did not fast intentionally for discipline or ritual. They experienced intervals without intake because their environment did not provide steady access. To understand why humans were never designed to eat every day, we must consider that these intervals were not rare interruptions. They were recurring features of survival. In mobile hunter-gatherer systems, daily caloric intake varied with success in hunting and gathering. A group might consume substantial energy following a successful hunt, then rely on stored reserves during quieter days. This oscillation created natural fasting periods embedded within subsistence patterns. Importantly, these intervals were typically short to moderate rather than extreme. They reflected normal ecological variability rather than catastrophic famine. The body's metabolic flexibility evolved to accommodate this range. Anthropological observations of more recent foraging societies provide cautious parallels. In some documented cases, individuals may eat heavily after a successful procurement event and consume less or skip substantial meals on other days. While such patterns differ across environments, they demonstrate that consistent daily intake is not universal in human subsistence strategies. These observations are not perfect mirrors of Paleolithic life, yet they echo a broader theme. Variability was expected. From a biological standpoint, these natural fasting periods reinforced the importance of fuel switching. When intake declined, glycogen stores would gradually diminish, and fat oxidation would increase. This transition allowed sustained energy supply without immediate harm. The brain, capable of utilizing glucose and, under certain conditions, ketone bodies, could maintain function during moderate gaps. Such adaptability would have been strongly favored in ancestral contexts. Individuals who tolerated intermittent absence of food without severe cognitive decline would be better positioned to secure future resources. The evolutionary origins of Homo sapiens in Africa were marked by environmental fluctuation. Rainfall patterns shifted, vegetation expanded and contracted, and animal populations moved in response. In such dynamic systems, the expectation of daily caloric certainty would be unrealistic. Instead, the body developed systems that anticipated interruption. These systems did not signal panic at the first missed meal. They activated gradual adjustments designed to preserve stability across time. Even social organization supported this rhythm. Sharing practices distributed surplus when available, but they did not eliminate fluctuation entirely. Community-level cooperation buffered risk, yet individual intake still varied. The body's capacity to manage these variations internally reduced dependence on perfect daily equality. When we ask why humans were never designed to eat every day, the historical presence of natural fasting intervals offers important context. The human organism evolved not under the assumption of uninterrupted feeding, but under conditions where intake ebbed and flowed. These ebbs were not pathological. They were part of the environment's structure. The metabolic architecture that remains within us today carries that history, reflecting a species shaped by cycles rather than by constant supply. If intervals without food were natural features of ancestral life, then the body's response to those intervals reveals how deeply they were integrated into human evolution. When intake paused, the organism did not interpret this as a malfunction. It shifted gears. This shift was neither dramatic nor chaotic. It followed predictable biochemical pathways that had been refined over countless generations. To understand why humans were never designed to eat every day, we must observe how smoothly these transitions occur when energy supply temporarily declines. During the early phase of reduced intake, the body draws upon glycogen stored in the liver. This reserve is limited but sufficient to maintain blood glucose within a stable range for many hours. As glycogen gradually decreases, hormonal signals adjust. Insulin levels fall and glucagon rises, encouraging the mobilization of stored fat. Fatty acids begin to circulate in greater quantities, supplying energy to muscles and other tissues. In longer gaps, the liver can convert some of these fatty acids into ketone bodies, which serve as alternative fuel sources, including for parts of the brain. This sequence reflects evolutionary preparation for fluctuation. It suggests that the body expects periods when external fuel is not immediately available. The presence of ketone metabolism pathways in humans is not an accident of modern dietary experimentation. It is evidence of a system designed to function during intermittent scarcity. In ancestral settings, such metabolic flexibility would allow continued movement, tool use, and social coordination during lean intervals. The brain's capacity to operate under these conditions is especially significant. Although glucose remains a primary fuel, the brain can adapt to utilize ketone bodies when availability shifts. This adaptation prevents abrupt cognitive failure in the absence of immediate intake. For a species whose survival depended heavily on planning, communication, and cooperation, maintaining mental clarity during temporary food gaps would have been crucial. If the brain rapidly deteriorated without constant feeding, the ability to secure future resources would diminish. Even muscle tissue shows adaptive restraint. In short-term fasting, the body preferentially conserves protein, relying more heavily on fat reserves. Only when deprivation becomes prolonged does significant muscle breakdown accelerate. This protective hierarchy suggests anticipation of recovery. It assumes that the lean phase will end and that food will eventually return. Such an assumption makes sense only within an evolutionary landscape where irregular access was common but not permanently catastrophic. From the perspective of human origins, these mechanisms reflect adaptation to environments where meals were opportunities rather than guarantees. Early Homo sapiens did not structure their days around predictable feeding intervals. Their physiology emerged from cycles of acquisition and pause. When modern life normalizes constant availability, the underlying biology does not disappear. It continues to follow patterns shaped in older contexts. Recognizing that humans were never designed to eat every day is therefore not a claim about what is ideal in contemporary society. It is a reflection of how the body's fuel systems were constructed. They were built to transition, to adjust, and to remain stable across uneven intake. That quiet flexibility remains embedded within us, a reminder of the fluctuating landscapes that once defined human survival. Beyond biochemistry, there is a behavioral dimension to these natural intervals without food. Early humans did not interpret hunger through nutritional charts or scheduled expectations. They experienced it as part of movement through landscape. The sensation would rise and fall as days unfolded, shaped by effort, climate, and opportunity. Because intake was not guaranteed each day, behavior had to remain functional across fluctuating energy states. To continue examining why humans were never designed to eat every day, we must consider how cognition and action were maintained during these pauses. Mild to moderate hunger does not automatically impair coordination or awareness. In many cases, alertness can remain intact for substantial periods without intake. From an evolutionary standpoint, this makes sense. A foraging species that became disoriented or lethargic after several hours without food would struggle to secure future resources. Instead, the nervous system evolved to sustain motivation and focus across natural gaps. Hunger acted as a directional signal, encouraging search and cooperation rather than as an immediate shutdown command. This capacity is visible even in contemporary observations. Short-term fasting often produces waves of hunger that peak and subside rather than escalating indefinitely. These waves reflect hormonal rhythms interacting with circadian patterns. The body is not rigidly programmed to demand intake at exact 24-hour intervals. It responds dynamically to context, memory of previous meals, and environmental cues. Such flexibility is consistent with an evolutionary history in which regular daily feeding was not structurally embedded. There is also evidence that early human activity levels did not always decline sharply during short lean periods. Movement across terrain, tool repair, and social interaction continued. The ability to act despite temporary caloric absence would provide a clear survival advantage. In fluctuating Pleistocene environments, resilience during these intervals could determine whether a group located new resources or missed them. Over generations, those who tolerated and functioned through moderate hunger would contribute more successfully to the gene pool. Importantly, this does not romanticize scarcity. Severe and prolonged deprivation carried genuine risks. Archaeological and paleopathological evidence confirms that malnutrition occurred in certain contexts. The key distinction lies in scale. Short, recurring intervals without food were likely common and manageable. Extended famine was harmful and often linked to environmental crises. The human body appears adapted to the former, not to the latter. When viewed against this deep background, the modern assumption that eating must occur daily to maintain stability appears historically narrow. It reflects agricultural and industrial conditions rather than the broader arc of human evolution. The rhythms of ancestral life included natural pauses in intake, and physiology adapted accordingly. Recognizing that humans were never designed to eat every day does not prescribe a specific pattern for contemporary living. It clarifies context. It reminds us that the human organism emerged in a world where hunger was intermittent and survivable, and where the capacity to function through those intervals was woven into the fabric of our species' long journey across changing landscapes. If daily eating was not structurally guaranteed, then the larger rhythm shaping human nutrition was not the day, but the season. Across much of the Pleistocene, climate determined what was available, when it appeared, and how long it lasted. Temperature shifts influenced plant growth. Animal migrations followed vegetation cycles. Rainfall patterns dictated the presence of water and the density of prey. To understand why humans were never designed to eat every day, we must widen our time frame beyond 24 hours and look at how food availability unfolded across months and years. In many environments inhabited by early Homo sapiens, seasons brought dramatic contrasts. During certain periods, herds gathered in predictable locations, creating opportunities for concentrated hunting. At other times, animals dispersed across vast territories, making procurement more uncertain. Similarly, fruits and seeds appeared briefly during growth cycles, then vanished. Tubers and underground storage organs could sometimes be accessed across wider spans, but their abundance still fluctuated with rainfall and soil conditions. These patterns suggest that food intake varied not only day to day, but season to season. Archaeological evidence supports this view. Isotopic analysis of animal remains often reveals seasonal hunting signatures. Growth rings in teeth and bones indicate that certain species were targeted during specific times of year. This implies strategic positioning by human groups who aligned their movements with ecological pulses. During these pulses, caloric intake might rise significantly. Outside them, intake would likely decline. The body's capacity to store energy during abundance and release it during scarcity aligns closely with such seasonal variability. From the perspective of human origins in Africa, early hominins lived through cycles of wet and dry phases that reshaped ecosystems. Lakes expanded and contracted. Grasslands alternated with wooded areas. These environmental oscillations structured subsistence opportunities across long spans of time. A physiology designed for strict daily constancy would struggle under such conditions. Instead, the human body evolved to navigate uneven landscapes, adjusting across extended temporal patterns rather than relying on daily guarantees. Even in colder regions colonized later by Homo sapiens, such as Ice Age Europe, seasonal contrasts intensified. Winters reduced plant availability and altered animal movement. Summer months offered richer opportunities. Groups adapted through mobility, cooperation, and strategic timing. Yet despite these adaptations, intake would still fluctuate across the year. Eating every day in uniform amounts was not the organizing principle. Alignment with ecological cycles was. When we examine why humans were never designed to eat every day, the seasonal lens clarifies the deeper structure. The human organism evolved in conversation with long environmental rhythms. These rhythms operated on scales larger than a single day. They rewarded flexibility, foresight, and storage capacity. The metabolic systems that remain within us today were calibrated against those extended cycles. Daily regularity is a recent cultural framework layered upon a much older biological inheritance shaped by seasons, migration, and climatic change. Seasonality did more than shape what foods were available. It shaped how much could be eaten over extended stretches of time. In many ancestral environments, abundance did not simply fluctuate from day to day. It rose and fell across longer arcs. A successful late summer period might allow higher caloric intake, while a harsh winter or dry season would compress access significantly. When we continue examining why humans were never designed to eat every day, we must consider how these broader oscillations structured the human relationship to energy itself. In temperate regions, plant productivity followed predictable annual cycles. Fruits ripened within narrow windows. Seeds matured and dropped within specific months. Underground storage organs were easier to extract when soils were moist rather than frozen. Animal bodies also changed seasonally. Fat accumulation in prey often peaked before winter migration, meaning that successful hunts during certain months yielded more energy per carcass than at other times. Early humans would have learned to track these patterns closely. Their intake, therefore, expanded and contracted alongside ecological opportunity. This rhythm suggests that calorie consumption across the year was uneven by design of environment. The body's ability to gain and retain fat during abundant periods can be understood as preparation for seasonal decline. Such storage was not a flaw. It was adaptive buffering against winter scarcity or dry season depletion. Paleoclimatic evidence from Africa and Eurasia reveals repeated environmental shifts that amplified this variability. In glacial cycles, colder periods reduced plant diversity and altered animal migration routes. Interglacial phases restored broader ecological productivity. Human groups survived across these fluctuations not by relying on daily intake guarantees, but by adapting to multi-month changes in availability. The metabolic system that emerged from these pressures became sensitive to patterns extending beyond 24 hours. It responded to cumulative trends rather than isolated meals. Seasonal variability also influenced social structure. During abundant months, larger gatherings might form around concentrated resources. During lean phases, groups might disperse into smaller units to reduce competition. These shifts would influence individual intake. Even if food was shared equitably within groups, the overall caloric environment still changed with the seasons. Thus, the expectation of identical daily consumption throughout the year would not align with ecological reality. From the standpoint of evolutionary time, the dominant temporal framework was not the clock or even the day, it was the cycle of climate. The human organism developed within this broader cadence. When food appeared, it was utilized and stored. When it diminished, reserves were mobilized and activity patterns adjusted. This extended oscillation reinforces the central theme. Humans were not shaped in environments of uninterrupted supply. They were shaped within ecosystems where intake rose and fell across months, sometimes dramatically. Recognizing this seasonal backdrop deepens our understanding of metabolic design. The body's conservation strategies, hormonal adjustments, and fuel switching capacities make sense when viewed against multi-month variability. Daily eating as an unquestioned norm belongs to a much later stage of human history. Beneath it remains a physiology tuned to seasonal pulses, a quiet inheritance from landscapes that offered abundance only in time-bound waves and required endurance between them. When we follow the seasonal thread to its deeper implications, we begin to see that human physiology was calibrated not only to short gaps between meals, but to longer arcs of relative abundance and relative restraint. The body's rhythms are layered. There are daily cycles tied to light and sleep. There are also longer cycles influenced by cumulative intake, body composition, and environmental cues. In ancestral settings, these longer cycles were shaped by climate and migration patterns rather than by fixed schedules. To continue asking why humans were never designed to eat every day, we must consider how these extended rhythms influence development across generations. Children growing up in seasonal environments would experience fluctuations in energy availability from an early age. Periods of relative abundance might support growth spurts. Leaner phases might slow growth temporarily without necessarily causing permanent harm. Over evolutionary time, developmental plasticity, the ability to adjust growth rates in response to environmental signals, would become advantageous. Such plasticity implies that the body expects variability rather than uninterrupted intake. It can adjust metabolic priorities depending on context. Even reproductive timing in humans shows sensitivity to energy balance over longer spans. In environments where food was scarce for extended periods, reproductive patterns could shift. Anthropological research suggests that sustained energy deficits can influence fertility, while improved availability supports it. This connection between energy and reproduction underscores how deeply seasonal intake patterns were integrated into human biology. The body does not operate as though daily feeding is the sole determinant of stability. It responds to broader trends in availability and reserves. Seasonal cycles also influence migration decisions. Groups might move toward regions offering temporary richness and away from those entering lean phases. Such movements required planning and coordination, and they further demonstrate that food was tracked over months rather than secured uniformly each day. The human nervous system and social structures evolved in conversation with these long rhythms. Anticipation of change, rather than reliance on constant supply, became central to survival. When agriculture eventually emerged, it began to compress these seasonal extremes. Cultivation and storage allowed more stable access across the year, though variability did not disappear entirely. Only in very recent history has technological infrastructure minimized seasonal fluctuation in many regions. Yet the biological systems shaped under earlier conditions remain largely intact. They were not redesigned within a few thousand years of farming or a few centuries of industrialization. This perspective reframes the question at the heart of our exploration. Humans were never designed to eat every day because the environments that shaped them did not function on a daily guarantee model. They functioned on seasonal pulses. The body evolved to navigate these pulses, storing during abundance and conserving during decline. The longer rhythm of climate, migration, and ecological productivity structured intake far more than the day itself. Beneath modern habits of regular meals lies a deeper metabolic memory, one attuned to seasons rather than schedules, and to endurance across time rather than constancy within 24 hours. If food availability fluctuated across days and seasons, then the structure of human groups had to adapt to that fluctuation. Early humans did not eat as isolated individuals. They lived in small bands where cooperation shaped survival. Within these bands, food distribution was rarely perfectly even from one person to the next, nor from one day to the next. To understand why humans were never designed to eat every day, we must examine how social organization influenced who ate, when they ate, and how variability was shared across generations. In mobile hunter-gatherer groups, successful hunting events often resulted in communal distribution. A large animal could provide significant calories, but it was too much for a single individual to consume quickly and would spoil if not shared. Sharing reduced risk at the group level. It meant that one person's success could buffer another's temporary failure. However, this system did not eliminate irregular intake. It redistributed pulses. If hunting success varied across days, the entire group experienced the broader pattern of abundance and scarcity together, though individual portions might differ. Archaeological and ethnographic studies suggest that age and status influenced access. Adults engaged in hunting and gathering would often receive priority portions of certain foods, particularly nutrient-dense tissues like marrow or organ meat. Children and older members were supported by communal norms, yet intake could still vary depending on overall success. The social system smoothed extremes, but it did not transform ecological fluctuation into uniform daily feeding. In fact, the need for cooperation may have reinforced tolerance for variability. A group that could endure days of modest intake without fragmentation or panic would be more resilient. Emotional and cognitive stability during lean periods supported cohesion. The human capacity for patience and delayed gratification may partly reflect this long exposure to uneven resource flow. In environments where immediate abundance could not be guaranteed, trust in shared distribution systems became essential. From the perspective of human origins, such social buffering would have emerged early. Fossil evidence indicates prolonged childhood in Homo sapiens, implying reliance on adult provisioning. This dependence required adults capable of maintaining function even when their own intake was irregular. The body's metabolic flexibility thus intersected with social structure. Adults who could tolerate intermittent scarcity were better able to support offspring through similar conditions. Over generations, this interplay between physiology and cooperation reinforced resilience to fluctuating access. It is also important to recognize that not every day required a full group hunt. Gathering activities, fishing, and opportunistic foraging contributed to daily sustenance in varying amounts. Yet even these sources were influenced by weather, season, and terrain. The social system reduced volatility but did not create certainty. When we reflect on why humans were never designed to eat every day, the communal dimension adds another layer. The expectation of consistent individual intake did not align with ancestral social realities. Intake was interwoven with group dynamics, shared effort, and collective adaptation to environmental pulses. The human organism evolved within this network of cooperation and variability, carrying forward a biology shaped not by isolated daily meals, but by communal endurance across uneven landscapes. Within small hunter-gatherer bands, food distribution was not only a matter of calories, it was woven into relationships, hierarchy, obligation, and trust. Sharing reduced the risk of any one individual facing prolonged deprivation, yet it did not eliminate fluctuation. The group as a whole still depended on the success of hunts, the ripening of plants, or the movement of animals. To continue understanding why humans were never designed to eat every day, we must examine how generational structure and social roles interacted with this variability. In many documented foraging societies, adults in their physical prime were the primary hunters of large game, while others specialized in gathering, tool maintenance, or childcare. This division of labor increased overall efficiency, but it also meant that caloric contributions were uneven across members. When hunting was successful, large portions of meat could be shared widely. When it was not, groups relied more heavily on gathered foods or smaller catches. Intake therefore shifted with both ecological and social factors. Children, who required steady energy for growth, depended on adults capable of maintaining function during irregular intake. This dependency likely reinforced metabolic resilience across generations. Fossil evidence indicates that Homo sapiens developed extended childhood compared to earlier hominins. Such prolonged development required stable caregiving in environments that were not always nutritionally stable. Adults who could endure short-term scarcity without severe impairment were better able to provision offspring over evolutionary time. This trait would become embedded. The capacity to function during intermittent hunger supported not only individual survival but also generational continuity. Older individuals also played roles within groups, contributing knowledge, memory of landscapes, and social cohesion. Their survival would depend partly on shared distribution. While younger adults might secure food, elders relied on communal norms that prioritized care. Yet the overall caloric environment still fluctuated. The presence of social support systems buffered risk, but it did not transform ecological unpredictability into guaranteed daily intake. Instead, it created a collective resilience that allowed the group to absorb variability together. The social brain of humans evolved within this context. Cooperation, empathy, and fairness norms developed alongside subsistence strategies. The ability to tolerate uneven intake without breakdown supported group stability. Emotional regulation during lean periods would help maintain trust. If hunger routinely led to conflict or disintegration, survival would be compromised. Thus, the interplay between metabolic flexibility and social cohesion reinforced adaptation to irregular eating. When we consider why humans were never designed to eat every day, the generational lens clarifies that this design was not solely about individual physiology. It was about a system in which individuals supported one another across fluctuating conditions. Daily constancy was not required for survival so long as cooperation distributed resources across time. The human organism, embedded within communal networks, evolved to navigate these shared rhythms. It carried forward a biology capable of enduring uneven intake, while sustaining both personal function and collective continuity. If food distribution within early human groups followed pulses rather than uniform daily allocation, then social expectations around eating would also reflect that pattern. There is little reason to assume that ancestral communities organized their identities around fixed meal times. Instead, eating was likely embedded within moments of opportunity after a successful hunt, during seasonal harvests, or when gathered foods accumulated sufficiently to be shared. To continue examining why humans were never designed to eat every day, we must consider how cultural norms around food would have formed in environments defined by variability rather than routine. In small, mobile bands, daily schedules were shaped primarily by light, weather, and movement. The absence of agriculture meant there were no fields requiring timed tending, and no storage facilities ensuring regular access. Without these structural anchors, meals would not need to align with a clock. They would align with acquisition. When food was available, it was consumed, shared, and sometimes preserved in limited ways. When it was scarce, attention shifted towards searching and conserving. Social memory likely revolved around successful procurement events rather than regular daily consumption. Even symbolic aspects of food rituals, storytelling, or communal gatherings would cluster around moments of abundance. Archaeological evidence of large hearths and dense bone deposits suggests that communal consumption followed successful hunts. These gatherings were significant not because they happened every day, but because they marked a temporary convergence of resources. In between such moments, daily life would continue with lighter intake or reliance on smaller, more dispersed food sources. Cultural patterns would therefore mirror ecological ones, episodic concentration followed by quieter intervals. This episodic structure has implications for how hunger was perceived socially. If everyone within a group experienced lean days together, hunger would not carry stigma or individual blame. It would be understood as a shared condition shaped by environment. Such collective experience may have reduced psychological distress associated with short-term scarcity. The normalization of fluctuation would reinforce metabolic and emotional resilience. In this context, daily eating would not be a cultural expectation but a fortunate outcome when conditions allowed. The transition to agriculture altered these patterns by creating greater regularity and encouraging fixed settlement. Over time, structured mealtimes became embedded in social organization. Yet this development occurred relatively recently, in evolutionary terms. For most of human history, cultural practices around food were aligned with mobility and environmental pulses. The absence of rigid daily eating norms would reflect and reinforce the biological flexibility already present. When we return to the central question, why humans were never designed to eat every day, the social dimension offers subtle confirmation. Cultural expectations evolved alongside ecological realities. In landscapes where intake fluctuated, norms adapted to that fluctuation. The human organism developed within communities that did not depend on daily regularity. Instead, they relied on cooperation, adaptability, and shared endurance across uneven cycles of abundance and scarcity. The emergence of agriculture marked one of the most significant shifts in the human relationship with food. For hundreds of thousands of years, intake had been tied to movement, season, and ecological pulse. With cultivation came a different structure. Plants were no longer only encountered, they were deliberately grown. Seeds were planted, tended, and harvested. Surplus could be stored in ways that mobility had previously limited. To understand why humans were never designed to eat every day, we must examine how this agricultural transition gradually reshaped expectations around regularity. Early farming communities began appearing roughly 12,000 years ago, in several regions including the Fertile Crescent, parts of East Asia, Mesoamerica, and Africa. The cultivation of cereals, legumes, and other staple crops introduced a more predictable food supply compared to foraging alone. While harvests were still vulnerable to drought, pests, and climate shifts, the general pattern allowed greater control over availability across seasons. Storage facilities, granaries, clay vessels, underground pits extended access beyond immediate harvest windows. This technological buffering reduced some of the environmental variability that had defined earlier human life. Yet even in early agricultural societies, daily certainty was not universal. Crop failures could produce lean years. Seasonal hunger, sometimes referred to as the hungry season, persisted in many agrarian communities. Nonetheless, compared to Paleolithic conditions, there was a gradual movement towards structured provisioning. Settled life encouraged division of labor around fields and domestic animals. With settlement came routines, meals increasingly aligned with work cycles rather than purely ecological pulses. The shift did not rewrite human biology overnight. The metabolic systems shaped during long pre-agricultural history remained largely intact. However, the environment surrounding those systems began to change. Instead of irregular pulses determined by wild migration and seasonal fruiting, communities began experiencing patterns structured by planting and harvest schedules. Over generations, cultural norms around eating became more regular. Morning and evening meals took on greater consistency. Social identity intertwined with cultivated staples. From an evolutionary perspective, this shift was relatively recent. Homo sapiens had already existed for the vast majority of their history without agriculture. The body's underlying design, refined across deep time in fluctuating ecosystems, did not fundamentally alter in the span of a few thousand years. Natural selection operates across much longer horizons. While some genetic adaptations to agriculture did occur, such as lactase persistence in certain populations or changes in starch digestion, the broader metabolic architecture remained rooted in earlier conditions. When we consider why humans were never designed to eat every day, agriculture represents a turning point in behavior rather than in foundational biology. It introduced greater regularity and the possibility of structured daily meals. Yet this cultural transformation sits atop a physiology shaped in a different context. The body that now receives predictable daily intake was formed in landscapes where such predictability did not exist. The agricultural shift therefore marks the beginning of a tension between ancient metabolic patterns and newly structured food environments, a tension that continues to shape human experience today. As agriculture matured, it did more than increase food supply, it reorganized time. In foraging societies, time was structured around opportunity, tracking herds, locating ripening plants, following water sources. With cultivation, time became cyclical in a new way. Planting, tending, harvesting, storing these activities created predictable annual patterns that gradually filtered into daily life. To continue understanding why humans were never designed to eat every day, we must observe how this restructuring of time encouraged the normalization of regular meals. Farming required settlement. Settlement required coordination. Fields had to be monitored. Irrigation systems had to be maintained. Livestock needed daily care. As work rhythms became more stable, food preparation and consumption increasingly aligned with those rhythms. Meals became markers within the day, punctuating labor cycles. Morning nourishment before field work, midday sustenance during rest, evening meals after labor. These patterns reinforced daily regularity. Over generations, cultural expectations formed around them. Eating at set times became part of social order. Yet this behavioral shift occurred within a body still shaped by far older ecological conditions. The underlying metabolic systems had evolved in response to variability, not to clocks. The expectation of steady daily intake was a cultural overlay rather than a biological redesign. Genetic adaptations to agricultural diets did emerge in certain populations, such as improved starch digestion or lactose tolerance. However, these changes affected specific nutrient processing rather than the fundamental structure of energy storage and release. The broader architecture, fuel switching, fat accumulation, hormonal regulation remained largely consistent with Paleolithic origins. Early agricultural communities were also not uniformly abundant. Archaeological evidence shows episodes of crop failure, malnutrition, and disease. Skeletal remains from some early farming societies indicate shorter stature and higher rates of nutritional stress compared to preceding foragers. This suggests that while agriculture increased predictability in some respects, it also introduced new vulnerabilities. Daily meals became more common, but quality and diversity sometimes declined. The transition was complex rather than purely beneficial. From a long evolutionary perspective, the agricultural shift spans only a small fraction of human history. For over 90% of Homo sapiens' existence, intake fluctuated with environment. The relatively recent establishment of regular daily meals did not erase the ancient metabolic patterns forged in fluctuating landscapes. Instead, it created a layered system in which cultural routines sit atop inherited biological flexibility. When we reflect again on why humans were never designed to eat every day, the agricultural era highlights the distinction between cultural design and evolutionary design. Agriculture reorganized social life and encouraged routine feeding. Yet the body beneath these routines still carries the imprint of a past in which daily intake was not guaranteed. The tension between structured meals and ancestral flexibility began here, as predictable fields replaced wandering herds and scheduled eating gradually replaced opportunistic nourishment. As agricultural systems stabilized in many regions, the idea of the daily meal became increasingly embedded in cultural identity. Grain cultivation encouraged storage. Storage encouraged planning. Planning encouraged routine. Over time, eating shifted from an event shaped primarily by ecological opportunity to one shaped by social structure. To continue exploring why humans were never designed to eat every day, we must consider how this normalization of daily intake gradually transformed expectations about hunger itself. In settled communities, food storage reduced immediate vulnerability to environmental fluctuation. Granaries and preserved goods created buffers that could extend access across weeks or months. This buffering allowed families to structure meals with greater consistency. Children grew up expecting regular nourishment. Social norms developed around shared mealtimes, reinforcing cohesion and hierarchy. Eating became not only biological but symbolic, an expression of belonging, tradition, and order. Yet the deeper metabolic architecture beneath these practices remained largely unchanged. The transition to agriculture occurred within the last 10 to 12,000 years, a brief interval compared to the hundreds of thousands of years of pre-agricultural human evolution. While certain populations adapted genetically to specific staples, such as dairy or high-starch diets, the fundamental systems governing energy storage, hunger signaling, and fuel switching did not undergo radical redesign. The body that now received predictable meals was still operating on programming shaped in far more variable environments. This divergence created subtle tension. Cultural expectations increasingly framed hunger as a problem to be avoided rather than a temporary signal. Regular meals reduced the frequency of natural fasting intervals. Over generations, societies came to equate stability with daily feeding. However, the biological systems that once managed irregular intake did not disappear. They remained capable of storing surplus and tolerating gaps, even if cultural norms discouraged experiencing those gaps. Industrialization further intensified this shift by extending agricultural predictability into year-round abundance. Transportation networks and preservation technologies diminished seasonal constraints. In many parts of the world, daily eating became not only possible but constant. Snacks and continuous access blurred the boundaries between meals. From a historical perspective, this represents an unprecedented environment. The human organism, shaped across deep time in fluctuating ecosystems, now inhabits a context of sustained availability. When we return to the central question why humans were never designed to eat every day, the agricultural and post-agricultural transitions clarify that daily feeding is a cultural development layered onto an older biological framework. The body's design emerged in landscapes without guaranteed constancy. Agriculture introduced routine, industry amplified it. Yet beneath these layers, the inherited metabolic patterns still reflect a species forged in irregularity. The normalization of daily meals marks a turning point in human history, but not a rewriting of evolutionary origins. If agriculture introduced regularity, the industrial era intensified it. Over the past few centuries, food production and distribution systems expanded beyond local fields and seasonal harvests. Mechanization increased yield, preservation techniques extended shelf life, Transportation networks connected distant regions, reducing reliance on local climate. In many parts of the world, daily eating became not only possible but expected. To continue understanding why humans were never designed to eat every day, we must examine how industrial food systems reshaped the human environment in ways unprecedented in evolutionary history. Industrialization altered both quantity and timing. Factories required workers to follow strict schedules, and meals adapted to those schedules. Breakfast before work, lunch breaks during shifts, dinner in the evening, these patterns solidified into social norms. Unlike agricultural societies, where seasons still influenced availability, industrial food supply increasingly detached intake from ecological cycles. Refrigeration, canning, and later global logistics ensured that food could be consumed year-round regardless of local production. The concept of hunger shifted from being a natural signal within fluctuating conditions to a cue to be addressed quickly and consistently. Urbanization further reinforced this pattern. As populations moved into cities, fewer people directly engaged in food production. Instead, food became a commodity purchased regularly. Shops stocked shelves daily. The rhythm of intake aligned more closely with economic and work structures than with migration or climate. This transformation occurred within a remarkably short period compared to the deep span of human evolution. The body that developed over hundreds of thousands of years in environments marked by variability suddenly encountered sustained abundance and predictability. Scientific and medical discourse also contributed to this shift. In the 19th and 20th centuries, emerging nutritional science emphasized regular meals to maintain energy for industrial labor. Caloric intake became quantified. Daily requirements were estimated and standardized. While these efforts aimed to prevent deficiency and improve productivity, they reinforced the expectation that eating should occur consistently each day. The idea that skipping meals might be tolerable under certain circumstances faded from mainstream perspective in many societies. At the same time, industrial food processing increased the availability of calorie-dense products. Refined grains, added sugars, and preserved fats became common. Continuous access reduced the natural pauses that once characterized intake. The modern environment in many regions now provides food not in pulses, but in an almost uninterrupted stream. This stands in contrast to the ecological backdrop that shaped human metabolic design. When we revisit the central question why humans were never designed to eat every day, the industrial transformation highlights the magnitude of environmental change. The expectation of 3 meals daily, supplemented by snacks, reflects cultural evolution rather than biological redesign. The body's storage systems, hunger signaling, and fuel flexibility were formed in fluctuating landscapes. Industrial abundance layered new patterns onto this older foundation. The result is a physiology operating within conditions that differ sharply from those in which it first developed, carrying forward ancient capacities into a world structured by modern constancy. As industrial systems expanded, the predictability of food was no longer limited to 3 structured meals. Over time, the boundaries between meals began to dissolve. Advances in preservation, packaging, and mass production made food portable, durable, and constantly accessible. Vending machines, packaged snacks, and convenience stores extended availability into nearly every hour of the day. In many societies, the experience of hunger shifted from an occasional signal within fluctuating conditions to something that could be immediately silenced. To continue exploring why humans were never designed to eat every day, we must consider how this near-continuous access represents a profound departure from ancestral conditions. In pre-industrial contexts, even agricultural societies experienced natural pauses between meals. Preparation required time. Ingredients were seasonal. Labor constrained frequency. Industrialization reduced these constraints. Food could be produced in surplus, stored for months, and transported across continents. Caloric density increased as refined sugars and fats became inexpensive and abundant. These changes did not alter human biology directly, but they altered the environment surrounding it. The metabolic systems shaped over deep time to manage intermittent intake now encountered sustained availability with minimal effort required to obtain it. Work patterns also shifted. As labor moved from physically demanding agricultural tasks to more sedentary occupations, energy expenditure declined in many populations. Yet the cultural norm of regular or even frequent eating remained. In some contexts, eating became intertwined with productivity, social interaction, and emotional regulation. Scheduled breaks were structured around food, social gatherings centered on meals and snacks. The expectation that energy must be replenished constantly reinforced the idea that daily intake was not only normal, but necessary for functioning. From an evolutionary perspective, this represents a compressed and intensified form of regularity. For most of Homo sapiens' existence, intake varied across days and seasons. With industrial food systems, variation diminished dramatically in many regions. The body's ancient mechanisms for storing and conserving energy remained intact, but the environmental cues that once triggered natural fluctuations became muted. Hunger could be addressed immediately. Surplus could be accumulated without seasonal constraint. The result is a metabolic system operating within a landscape of unprecedented constancy. When we ask again why humans were never designed to eat every day, the industrial era clarifies that daily feeding, particularly in continuous or frequent patterns, is a recent cultural development. The body did not evolve under conditions of round-the-clock access. It evolved under conditions where effort, season, and cooperation determined intake. Industrial abundance layered new expectations onto this older framework, creating a contrast between inherited biological rhythms and modern environmental structures that encourage constant nourishment. As industrial systems matured and food became steadily available, the cultural meaning of hunger shifted even further. In earlier environments, hunger had been a signal embedded within ecological cycles. It marked a temporary phase between opportunity and the next acquisition. In the modern setting shaped by industrial abundance, hunger increasingly came to be interpreted as something abnormal, something to prevent rather than to understand. To continue examining why humans were never designed to eat every day, we must look at how this reinterpretation altered the relationship between body signals and behavior. When food is constantly present, even mild sensations of hunger can be resolved immediately. Over time, this can weaken tolerance for natural fluctuations in appetite. The body still produces waves of hunger signals through hormonal rhythms, but cultural expectations now encourage rapid response. The interval between signal and consumption shortens. In ancestral contexts, that interval might extend for hours or longer, while individuals continued to function and search. In the industrial context, the same signal may be met with instant intake, reducing exposure to the body's full adaptive range. This does not imply that modern patterns are inherently harmful. It illustrates contrast. The metabolic system shaped across hundreds of thousands of years was built to navigate irregularity. It assumed that intake would not always align neatly with daily cycles. When that assumption is replaced by uninterrupted access, the environment changes faster than the underlying biology. The body still retains mechanisms for storage and gradual release, even if they are now less frequently engaged in their original rhythm. Another layer of this shift lies in perception of energy needs. Industrial societies often equate constant productivity with constant fueling. The idea that one must eat at fixed intervals to maintain performance has become widespread. Yet the evolutionary record suggests that humans remained capable during natural pauses in intake. The capacity to think, move, and cooperate during lean intervals was not accidental. It was selected for across generations living in fluctuating landscapes. By reframing hunger solely as a deficit requiring immediate correction, modern culture may obscure this inherited resilience. From a historical perspective, the normalization of daily and sometimes continuous eating is a narrow chapter in the long human story. For the vast majority of that story, intake was variable, and the body adapted accordingly. Industrial abundance represents a rapid environmental shift layered upon an ancient metabolic blueprint. When we return to the central question why humans were never designed to eat every day, the contrast becomes clearer. The design emerged under conditions where irregularity was normal and survivable. The expectation of constant daily feeding reflects cultural evolution rather than biological necessity. Beneath contemporary habits, the human organism still carries the imprint of a past in which hunger rose and fell within broader rhythms, and where endurance between opportunities was part of what it meant to survive. When ancient metabolic systems operate within modern conditions of constant availability, subtle mismatches can emerge. The human body evolved to manage fluctuating intake, storing energy during abundance and releasing it gradually during scarcity. In environments where abundance is continuous, those same mechanisms continue to function as they always have. They store when insulin rises. They conserve when energy appears plentiful. To understand why humans were never designed to eat every day, we must observe how this inherited design behaves when daily feeding becomes uninterrupted and often excessive. One of the most discussed consequences of modern abundance is the rising prevalence of metabolic disorders. Conditions such as insulin resistance and type 2 diabetes are complex and influenced by many factors, including genetics, activity levels, and overall diet composition. Yet, at their core lies a pattern of persistent energy surplus. When food is consumed regularly throughout the day, especially in calorie-dense forms, insulin remains elevated for extended periods. The body continues to store energy even when long-term reserves are already substantial. In ancestral contexts, elevated insulin would signal a temporary window of opportunity store now, because scarcity may follow. In modern contexts, scarcity may never arrive, yet the storage machinery remains active. This does not mean that daily eating alone causes metabolic disease. The picture is far more nuanced, involving processed foods, reduced physical activity, sleep disruption, and stress. However, the mismatch between ancient storage bias and sustained abundance contributes to the environment in which these conditions develop. The body's preference for conservation, once protective, becomes less adaptive when intake rarely declines. From the perspective of evolutionary time, this shift is abrupt. Homo sapiens lived for hundreds of thousands of years in landscapes where daily caloric certainty was rare. Only within the last few centuries has consistent, year-round access become widespread in certain populations. Natural selection has not had sufficient time to redesign the metabolic blueprint in response to this new environment. The inherited systems continue to anticipate fluctuation, even when fluctuation is minimized. Beyond insulin dynamics, constant feeding can reduce engagement of fuel-switching pathways that once operated regularly. When intake is continuous, the transition to fat utilization occurs less frequently. The metabolic flexibility that evolved to handle irregularity remains present, but it may be used differently. This altered pattern reflects environmental change rather than biological failure. When we revisit the central question, why humans were never designed to eat every day, the modern metabolic landscape illustrates the tension between design and context. The body was shaped for cycles of abundance and pause. It remains equipped to manage those cycles. In an environment of uninterrupted intake, the ancient bias towards storage continues quietly, operating as it always has. The result is not proof that daily eating is inherently wrong, but evidence that our physiology was forged in conditions where constancy was the exception rather than the rule. Beyond insulin and energy storage, the experience of constant availability influences how the brain interprets appetite. The human nervous system evolved to respond to scarcity with heightened motivation. Food seeking required attention, planning, and cooperation. In environments where intake fluctuated, reward circuits reinforced successful acquisition. When a hunt succeeded or a gathering yielded abundance, the resulting nourishment carried not only calories, but also reinforcement signals. These signals strengthened behaviors that improved survival. To continue exploring why humans were never designed to eat every day, we must consider how these ancient reward systems behave in modern conditions of continuous access. Dopamine pathways in the brain play a central role in motivation and reward. In ancestral contexts, these pathways would activate during successful food procurement, encouraging repetition of effective strategies. Importantly, the effort required to obtain food was substantial. Tracking prey, digging for tubers, or traveling long distances demanded energy. The reward was proportional to effort and scarcity. In modern environments, calorie-dense foods can be obtained with minimal physical cost. The same neural circuits that once responded to rare success now encounter frequent stimulation. This does not imply that the brain is defective. It suggests that its calibration occurred under different environmental assumptions. Continuous exposure to easily accessible, palatable foods can alter the pattern of appetite signals. When intake becomes frequent, hunger may become less tied to energy deficit and more influenced by cues such as sight, smell, habit, and emotional context. The body still produces hormonal rhythms shaped by evolutionary history, but the environment now offers immediate satisfaction at nearly every cue. The natural pauses that once allowed hunger waves to rise and fall are shortened or removed. From a historical perspective, this shift is recent. For most of human existence, food seeking required patience. The reward system reinforced persistence through uncertainty. Today, in many regions, uncertainty is reduced. The metabolic and neural systems shaped in fluctuating landscapes must now navigate environments of predictability and abundance. The resulting patterns, such as eating in response to stress or boredom, reflect complex interactions between ancient circuitry and modern context. It is important to approach this topic without simplification. Human appetite is influenced by culture, emotion, social norms, and physiology. There is no single cause behind modern eating behaviors. However, when we ask why humans were never designed to eat every day, the role of reward systems adds another dimension. These systems evolved to manage intermittent access, reinforcing effort and tolerating gaps. In a world where food is constantly available, the same circuits operate under altered conditions. The ancient motivational architecture remains intact, even as the surrounding environment has changed. The body and brain continue to function according to patterns forged in scarcity, adapting as best they can to an era of sustained abundance. When we bring together storage systems, hormonal regulation, and reward circuitry, a larger pattern becomes visible. The human organism is not malfunctioning in modern environments. It is behaving consistently with instructions written across deep evolutionary time. Those instructions assumed fluctuation. They assumed that food would appear and disappear. They assumed that effort would precede reward. To continue examining why humans were never designed to eat every day, we must recognize that what appears as modern difficulty may instead be ancient programming operating in a new context. In environments of constant availability, the body still follows its conservative bias. It stores energy efficiently when intake exceeds immediate needs. It protects reserves when intake declines only briefly. It responds to palatable foods with strong reinforcement signals because such foods once indicated rare opportunity. None of these responses are inherently pathological. They are coherent within the environmental frame in which they evolved. The challenge arises when environmental constancy overrides the natural cycles those systems anticipate. In ancestral landscapes, a period of abundance would likely be followed by relative scarcity. Storage would be utilized. Hormonal patterns would oscillate. Reward circuits would rest between procurement events. In modern settings, abundance can persist without meaningful interruption. The cycles compress or flatten. The body continues to store, but the anticipated lean phase may not arrive. Over time, this can create strain within metabolic pathways that were optimized for oscillation rather than perpetual surplus. It is important to avoid simplistic conclusions. Not all modern societies experience the same abundance, and not all individuals are affected in the same way. Physical activity, dietary composition, sleep, and stress all influence metabolic health. The evolutionary perspective does not reduce complexity. Instead, it provides context. It reminds us that the human design emerged under conditions unlike those many people experience today. When we ask why humans were never designed to eat every day, the answer is not a moral judgment about eating patterns. It is a reflection on history. For the vast majority of our species' existence, daily intake was not guaranteed. Natural pauses between meals were common. Storage and release formed a balanced rhythm. The modern environment has altered that rhythm in many places, but it has not rewritten the underlying blueprint. The body remains adapted to cycles. It anticipates variability. It conserves against uncertainty. Recognizing this does not require rejecting contemporary life. It requires understanding that beneath modern routines lies a physiology shaped by irregularity. The tension we observe today is not evidence of human weakness. It is evidence of continuity, an ancient metabolic architecture meeting a rapidly transformed world, still following patterns forged in landscapes where tomorrow's meal could never be assumed. When we use the word designed, we must pause carefully. Humans were not engineered with a blueprint in the mechanical sense. There was no deliberate plan assigning meal frequency or specifying optimal intervals between nourishment. The human body emerged through natural selection, shaped gradually by environments that rewarded certain traits over others. To continue asking why humans were never designed to eat every day, we must clarify what design means in an evolutionary context. Evolution does not optimize for comfort or convenience. It optimizes for survival and reproduction under specific conditions. For most of human history, those conditions included ecological variability. Food availability rose and fell with seasons, migration, and climate. Individuals whose bodies could tolerate irregular intake without severe impairment were more likely to persist across generations. Over time, metabolic flexibility, efficient storage, and resilience during short-term scarcity became widespread characteristics. These features were not crafted for modern abundance. They were filtered by environments where constancy was rare. The word designed therefore reflects accumulated adaptation rather than intention. Humans were shaped for oscillation because oscillation was common. The expectation of daily intake did not dominate ancestral landscapes. Instead, survival favored those who could endure gaps and capitalize on opportunity. This evolutionary framing also prevents oversimplification. It does not claim that daily eating is unnatural or inherently harmful. Humans are adaptable. Our species has thrived across diverse ecological niches, from tropical forests to Arctic tundra. Cultural evolution has allowed new patterns to emerge, including structured meals, yet cultural change operates more rapidly than genetic change. The body we carry today retains the imprint of deep time even as we inhabit new environments. Recognizing this distinction helps avoid moral or prescriptive conclusions. The central insight is historical rather than ideological. For the overwhelming majority of Homo sapiens' existence, eating every day was not guaranteed. The physiology that emerged reflects that history. It anticipates variability. It stores against uncertainty. It tolerates short intervals without intake. These traits are not flaws to be corrected. They are legacies of survival. When we ask why humans were never designed to eat every day, we are really asking how evolutionary pressures shaped metabolic architecture. The answer lies in the environments that selected for flexibility rather than rigidity. Our bodies were shaped in landscapes where food was encountered, not scheduled. The concept of a guaranteed daily meal is a cultural development layered upon a much older biological foundation. Understanding this foundation invites reflection rather than alarm. It reminds us that the human organism is a product of long adaptation to fluctuating conditions, carrying forward ancient capacities into modern life. If design in evolution means adaptation to past environments, then understanding that past becomes essential to interpreting the present. The human body was shaped in contexts where uncertainty was normal. Yet it is also true that humans are highly adaptable. Cultural practices can shift more rapidly than genes, and behaviors can modify how inherited systems are expressed. To continue exploring why humans were never designed to eat every day, we must consider how adaptation and flexibility coexist within the same organism. Throughout history, human populations have adjusted to new food sources and new rhythms. The adoption of agriculture led to genetic adaptations in some groups, such as the persistence of lactase into adulthood or increased efficiency in starch digestion. These changes illustrate that biology can respond to sustained environmental pressures. However, such adaptations are typically specific rather than comprehensive. They modify certain pathways without rewriting the broader metabolic architecture that evolved over much longer spans of time. The core systems of storage, hunger signaling, and fuel switching remain deeply rooted in pre-agricultural conditions. This layered structure means that humans can function under regular daily eating patterns while still carrying physiology shaped by irregular intake. Adaptation does not erase history, it builds upon it. In modern societies, many individuals eat daily without immediate harm. The body accommodates this pattern because it is flexible, yet flexibility has limits. The evolutionary backdrop reminds us that daily feeding is a cultural norm rather than a biological requirement. The body can manage it, but it was not originally calibrated around it. Another dimension of adaptability lies in perception. Cultural narratives about food influence how hunger is interpreted and responded to. In societies where regular meals are expected, mild hunger may be perceived as discomfort requiring immediate resolution. In other contexts, similar sensations might be tolerated without distress. This variation demonstrates that human experience of eating patterns is shaped not only by biology, but also by meaning. Evolution provided the physiological framework. Culture shapes its expression. When we reflect again on why humans were never designed to eat every day, the answer does not demand rejection of contemporary habits. It invites awareness. It highlights that the human organism emerged from environments structured by fluctuation. The capacity to endure short intervals without intake is part of that inheritance. Regular daily meals are a relatively recent development layered upon this foundation. Recognizing the difference between biological adaptation and cultural routine allows a more nuanced understanding. Humans are neither rigidly bound to ancestral patterns nor entirely detached from them. We live at the intersection of deep evolutionary history and rapid cultural change, carrying forward a body shaped for variability into a world that increasingly values constancy. When we reach the end of this long reflection, the question remains quiet rather than dramatic. The human body was shaped in landscapes where food was encountered, not scheduled. It learned to store when abundance appeared and to endure when it did not. It developed hormonal rhythms that anticipate fluctuation, neural circuits that reward effort, and social patterns that distribute pulses of nourishment across time. None of these systems were engineered with a daily guarantee in mind. They emerged gradually, molded by climates that shifted and ecosystems that never promised constancy. To understand why humans were never designed to eat every day is not to condemn modern habits. It is to recognize the depth of the past within us. For the overwhelming majority of our species' existence, eating every single day was not assured. The body that survived those ages carries a memory of variability. It expects cycles, not permanence. Yet humans are also adaptable. Agriculture reshaped food rhythms. Industry intensified them. Culture layered structure upon instinct. The body did not resist these changes outright. It accommodated them as best it could, using the same ancient mechanisms of storage, release, and regulation. In many parts of the world, daily meals have become ordinary, even comforting. They reflect stability, security, and social connection. Evolution does not forbid this stability. It simply reminds us that it is recent. Beneath the routine of breakfast, lunch, and dinner lies a physiology formed in movement and uncertainty. Recognizing this does not require radical action. It invites awareness. It suggests that sensations of hunger are not always emergencies, that pauses between meals are not inherently unnatural, and that the body's conservative bias towards saving energy once carried deep survival value. It also invites humility. Human biology is not broken because it stores. It is not flawed because it responds strongly to food cues. It is operating according to instructions written long before agriculture or refrigeration. The tension between ancient design and modern environment is not a moral failure. It is a historical reality. As you consider your own rhythms of eating, perhaps the more meaningful question is not whether daily meals are right or wrong. It is whether we can understand the quiet history beneath them. The body you inhabit today is the product of landscapes where tomorrow's food was uncertain, where seasons shaped appetite, and where endurance was part of survival. In a world of constant availability, what might it mean to live with awareness of that older rhythm still present within you?